Hello everyone. So today's topic is the second part of Amazon VPC, and here we will be covering network address translations, that is NAT, and access control list. And the rest topics we will be covering in our next video. So stay tuned for that. So first of all, means this will be a lab session, and before that let me give you an overview of what is network translation, address translation. Essentially, we need to just here what we need to do in this lab is we need to just enable our EC2 instances in our private subnet, means our DB server, uh, to still be able to go and download software, and in order to do that we need to communicate that to our internet gateway. However, what we don't want to do is make our subnets public. In the real world, you will be always be using NAT gateways. NAT instances are individual EC2 instances. This is the main difference between NAT instances and NAT gateways. NAT instances are individual EC2 instances, whereas NAT gateways are highly available. They are not just one EC2 instance, they are spread across multiple availability zones. They aren't dependent on a single instance. So let's go ahead and log into our AWS console. So here we are in our AWS console. From here, let's go to EC2. So let's launch our instance. We'll go to community AMIs, and here we will type in NAT and press enter. And this will give our NAT instances, and we'll go ahead with this one. General purpose T2 tier. So here we will be giving our VPC, and I need to make ensure that this is in our public subnet. This thing we need to enable. Then next we will be adding tags, storage, then tags, then add a tag. Let's give the name key as name, and here NAT instance. Then security group we can take from our default security groups. Let us take this one, or public. Let us take this one in a public security group. Then review and launch. We'll take this as make general purpose SSD the boot volume for this instance. Next, and then launch, and choose an existing key pair. So I have my private and public both in here. So let me take this one as public. Let me check once more whether I am having this or not. Yes, I do have my public.pem. Then launch instances. So this will be getting launched. We can check it out from here itself. So this is in pending status. NAT instances act as a gateway to the internet gateway. You can say, means it just for your understanding only, I'm saying NAT instances act as a gateway to the internet gateway. It acts as a bridge between our private subnet through the public subnet to the internet gateway. And to make this as a gateway, we need to disable source and destination check, which is enabled by default. So how do we do it? So if you go through the instance, the documentation for the NAT instances, you can see everything is given in here, and how to set up the NAT instance. If you go down much more, you can see here disabling the source and destination checks. Each EC2 instance performs source or destination checks by default. This means that the instance must be the source or destination of any traffic it sends or receives. However, a NAT instance must be able to send and receive traffic when the source or destination is not itself. Therefore, you must disable source destination checks on the NAT instance. So, right now, since this is enabled by default, we need to disable it. So, how do we disable? Go to NAT instance, then networking, then change source destination, yes, disable. So, currently this is disabled. Now, in order to get my DB server, this is my DB server which is in public private zone. In order to get my DB server to talk to my NAT instance, we need to create route in default route table. So, let us go to VPC again in network and content delivery, and in here let us go to our route table. So, here we will go to our main VPC, main route table, then go to routes, edit routes, then add in here add my IPv4 address and the target as our NAT gateway. Sorry, this should be instance, my NAT instance. So, basically this will be means we can reach out to the internet. For that we are giving this IP address, and we are right now we are saving it. So, right now we hope that we will be able to access to our private instance will be able to access in here. So, let us check whether we can do it or not. For that, first of all, we need to log into our public EC2 instance, which is my web server, and this one. So, I am in my private server, and I will elevate my privileges to root. So, I have my this thing my private.pem in here. Let me check my private IP address. So, this is my private IP address, I am just copying it, and then I will SSH to my private private EC2 instance. With this key. So, right now I am in my private EC2 instance, and let me check whether I am able to yum update right now or not, because in our previous video you could see that we were not able to yum update. So right now this is able to connect to the internet and it is able to update its kernels. This is not possible if the NAT instance is terminated. I'll just pause the video until this is done. So this is done and I'm able to update my server, my private server. So if you go to in here, in VPC, to my root tables and click in this one, you can see the status is active. Right now I will terminate this, or I'll just stop it. I'll just terminate in it. This was a small instance, but imagine there is a very big network. NAT instances has just bottlenecks. You see, it is a single network in a single availability zone. As the business gets larger and larger, scaling is required. But if we are relying on a single OS, so if it crashes, then we will lose the internet access for all service behind private subnets. So that is why I'm right now what I'm doing is that my NAT means I'm showing you in here is that my NAT instance got terminated, so it got crashed. And right now we will be checking whether internet access is there or not for my private subnet. So I am already logged in here, and let me see yum install httpd hyphen y. Let me see whether this Apache gets installed or not. So this is getting installed right now, by the way. No, this is not getting installed. You can see in here it's trying to install, but it is failing. It is trying from every system, and since there is no internet, it is failing. So now what we need to do is that let us go to our route table, which is in VPC, and check the status in here. You can see the status has changed to black hole. Since our NAT instance has been terminated, the status has changed to black hole, and we can just remove it from here. So this is done. Now let's go ahead and create a NAT gateway and perform the operation. I'm just cancelling this. You need to remember is that NAT gateways operate on IPv4, whereas egress only internet gateways operate on IPv6. So we are right now we are concerned with NAT gateways. We are in NAT gateway and we need to create a NAT gateway. Subnet. Let us take our public subnet. This is my public subnet. Elastic IP address. Allocate. So I'm just creating one. Then create a NAT add tag. Name and the value let me give as my infra NAT. Then create the NAT gateway. And after this is done, your NAT gateway is created. In order to use your NAT gateway, ensure that you edit, you edit your route tables. So right now I am in my route table. We will be editing this, our main route table. Add route to the internet. And let's take our NAT gateway. So this is our NAT gateway. Save routes. So this is done. Right now, let me check this command once more. So it is able to reach out to the internet and complete Apache installation in here. So going ahead with our theory part, if you have resources in multiple AZ and they share one NAT gateway, in the event that the NAT gateway's availability zone is down, resources in the other availability zones lose internet access. To create an availability zone independent architecture, create a NAT gateway in each availability zone and configure your routing to ensure that resources use the NAT gateway in the same availability zone. So what about NAT instances? When creating a NAT instance, disable source and destination check on the instance. NAT instances must be on a public subnet. This you need to remember for your exam. There must be a route out of the private subnet to NAT instance in order for this to work. The amount of traffic that NAT instances can support depends on the instance size. If you are bottlenecking, increase the instance size. You shouldn't be using T2 micro for NAT instances. Here we have used this for our own purpose, since it is a free tier version. You can create high availability using auto scaling groups, multiple subnets in different availability zones, and a script to automate failover. NAT instances are behind a security group. What about NAT gateways? They are redundant inside the availability zone. NAT gateways cannot span availability zone. They are preferred by business and enterprise customers. They can scale automatically up to 45 Gbps from 5 Gbps. There's no need to patch them. They are not associated with security groups. They are automatically assigned a public IP address. Remember to update your route tables and point them to your NAT gateways. This you need to do while creating your NAT gateway. There's no need to disable source destination checks. They are more secure than a NAT instance. You do not need to have SSH access to NAT gateway, and there is no need to worry about patching antivirus. Our next topic is access control list. ACL is nothing but access control list. Network ACLs can be deployed into one VPC and it cannot span into multiple VPCs. By default, you create a private network access control list. Everything is denied in both inbound and outbound rules. We will go by the lab first of all, where we will be creating a network access control list, and then from our public EC2 we will try accessing it. So to test this, we need to by setting up a web page on our web server. So here we are in our private EC2 instance. I will just log out from here, and here we are in our public EC2 server right now. From here, let me check with what is the condition of my could not be found. So I just install my Apache, and then check config HTTPD on, so that I ensure that it is when my system is rebooted, this is still there. Service HTTPD start. So this is running right now. We will go to cd var www html, and in here I'll create a file .html and well, I believe its network is pretty slow. I'll write a HTML script. Hello infra experts. Please do like and subscribe my video, my channel, and I will just close it. I'll take the IP address of my EC2 instance. So this is my EC2 instance. I'll take the IP address from here. I'll just paste it in here, and let's see. So this is working. Hello infra experts, please do like and subscribe my channel. The reason why this is working is that the subnet is currently associated with our default subnet, and our default subnet has inbound rule to allow everything. Now let's go to our new network access control list, which is in VPC. So here we have two. One is the default one, and the other one is this with two subnets. And in here, let us go to subnet associations. I will just do this thing, subnet associations, then edit this, and we'll add the public subnet. This is the public subnet. Well, currently what is it in here? Our private and public both are associated with this VPC. And you can see in here the inbound rules. You can see the rule number 101 and 100 and 101, those are allowed, and the other those are in deny status. As in the outbound rules also, it is the same. So in order to use our network ACL, let us go ahead and create a network ACL, and I will give this name as my infra NACL, and the VPC I'll take this one and create it. So in here you can, in the new NACL, you can see everything is denied by default. What I will do right now is I'll edit the subnet associations and will take my public subnet. So right now my public subnet is in here, and you can see that this has gone from here. So right now the default NAT NACL is having just my private subnet. And right now let us refresh the web page. So it is right now, it is just searching for it. It is just searching for the video for my for the web page, and it will just fail. So it has failed right now since I have changed my network ACL. Now to fix this, let us edit the rules in here. So in inbound rules, we need to edit it and add rule number 100. The port range is 80 and the source is this. Rule number 2, 200, 443, which is HTTPS, and this one for my SSH port. Save. Similarly, for my outbound rules, 100, the port range for HTTP, 200 for HTTPS, 1024.26553.5, which is my ephemeral ports. Now let me hit refresh to my web browser, and this comes. Now let me add a denial rule for my in the inbound. Before that, let me check what is my IP address. So this is my IP address. Let me add a rule in here, 400. The range as 80/32, deny and save. And let me check whether right now this is working or not, and it should be working, and it is working. Right now let me edit it and put this rule as, let's say, 50 and save. You can see this came at the top, and let me refresh it. So this will again, it won't be working. As you can see in here, this is trying to search, and then it will fail. So as you can see in here, this site cannot be reached and it is failing, because from here what we can infer is that rules are validated in incremental order. So for this example, the first rule says that the incoming connections aren't allowed. That's why this will be overcoming this rule. Rule 50 is overcoming rule 100. So let us go to our exam tips. You need to remember something is that a subnet can be associated with only one network access control list, and NACLs can be used to block specific IP address, and they can be used to they can also be used to block specific IP address ranges. So your VPC automatically comes by default a network access control list, and by default it allows all outbound and inbound traffic. You can create custom network ACLs. By default, each custom network ACL denies all inbound and outbound traffic until you add rules. Each subnet in your VPC must be associated with a network ACL. If you don't explicitly associate a subnet with a network ACL, the subnet is automatically associated with the default network ACL. You can block IP addresses using network ACLs, but you cannot do the same with security groups. You can associate a network ACL with multiple subnets. However, a subnet can be associated with only one network ACL at a time. When you associate a network ACL with a subnet, the previous association is removed. So network ACLs can span availability zones, whereas subnets cannot. Network ACLs can NACLs can contain numbered list of rules that is evaluated in order, starting with the lowest numbered rule, as you saw in my example. Network access control lists have separate inbound and outbound rules, and each rule can either allow or deny traffic. Network access lists are stateless. Responses to allow inbound traffic are subject to the rules for outbound traffic and vice versa. In security groups, if you open a port 80, you aren't allowed to block a specific IP address. Ephemeral ports are on outbound rules of NACL. So that is all about for this video. So we will be looking into our next video, where we will discuss on custom VPCs and elastic load balancers, VPC flow logs, bastions, direct connect, VPC endpoints, and I hope we can conclude this in a single video. Thank you. So if you do like my video, please like and share and subscribe. Thank you.